Hello again, everyone. As before, we hopefully get time for questions in this one, so the more towards the centre you are, the less we have to run, and the more likely we are to be nice to you when we give you the microphone. Michael is an active OpenStack community... I can't English, sorry. Michael is an active OpenStack compute developer and has previously served as the compute project technical lead, a compute and Oslo core reviewer, and also serving as the OpenStack-wide technical committee. Even big projects with seasoned teams can make mistakes, and Michael is going to tell us about what we can learn from them so we don't make those same mistakes. Hint, we will do them anyway. Please welcome Michael.
Thank you. So the title of the talk is Learning from the Mistakes that Even Big Projects Make. OpenStack is a little bit smaller now than it used to be, but it was, by all measures, a big project. In a single release, we'd have 3,000 active developers. We'd release every 6 months. There were millions of lines of code. It was a very rapidly moving, dynamic place to be. And we still made a whole bunch of really dumb mistakes, despite the fact that we had effectively infinite resources to play with. And so we're going to talk about that a little bit. My name's Michael, as was previously mentioned. I've been working on OpenStack since 2011. I've been a Python programmer a bit longer than that. And I currently work for a company called Aptera that does OpenStack, software-defined networking, and orchestration consulting. The punchline there is I'm not a security professional. In fact, I think a lot of people who used to work with me, like Richard, would say I'm not a professional at all. But the point is, I'm trying to have a conversation at kind of a programmer level, so I'm sure people might call me on some of the stuff I say, and that's okay, call me on it, and we'll see where we go. So, OpenStack is a way of setting up virtual machines on clusters of computers, and the stuff those virtual machines need, which is generally virtual storage and virtual networks. So at a really high level, if I was explaining this to like a manager type, you could just have a basement full of system admins frantically doing tickets as fast as they can, and you don't really need OpenStack. In fact, I've worked in that company, and they had a shopping mall full of system admins. It was a weird life. The difference with OpenStack is that it scales better, and what it does is repeatable. So when you need to go and debug how it's set up a virtual machine, it's predictable the way it's done it because it's done by code and it's always done the same way. But, you know, fundamentally, OpenStack needs to do exactly what a system admin sitting at a desk would have to do in order to set up a VM, to the point where it literally executes the command lines that you would cut and paste off StackForge or whatever in order to do that thing. So it spends a lot of its time with escalated permissions, is I guess what I'm trying to say. You can think of it as your Python system admin. Now, the other thing I should say at the beginning is I wrote an abstract for this talk and I felt very smart. And then I was talking to someone I respect a lot last weekend, and they pointed out that good conference talks aren't war stories, they're actionable. And I went away and thought about that, and I've actually blown up my talk and rewritten it to try and be more actionable. And so that means it doesn't completely map to the abstract that's on the conference website. I do apologise for any delta, but I think, to be honest, this is a better talk. So we'll just roll with it and see where we end up. Okay, so how do other people deal with having, say, systems that need escalated permissions to do something that you'd think of as having been done by root? The example I wanted to pick on was Kubernetes. The problem is Kubernetes doesn't actually do this. So when you want to start a container with Kubernetes, Kubernetes goes and talks amongst itself and decides what to do, but then it goes and asks a thing called a container runtime to start the container. And for 99% of Kubernetes deploys, the container runtime is a thing called Docker. So how does Docker do this? It's actually really interesting. So Docker has an API. It uses a thing that feels a lot like HTTP, but it's exposed through a thing called a Unix domain socket, which is a thing that exists in your file system. And then they protect that with exactly Unix file system permissions. So if I want to control who can start a container or stop a container or do any of that containery stuff with Docker, what I do is I add you to the group that owns that socket in the file system. And that's as granular as it gets. So, in fact, the Docker documentation says, adding someone to the Docker group is equivalent to giving them root permissions on your system. Now, it's not as bad as it might seem, because Docker doesn't do that thing over the network. You can optionally expose that API over TCP, but I think you'd be fairly brave. But that's why you're running something like Kubernetes, which is the thing that's managing talking across the network and the trust domains and all of that kind of stuff. And then Docker's an engine to do things on a local box once you've already trusted the request. So I guess we could think about this as option 1 for doing things with escalated permissions, which is to punt and just do it bad. The next step up is you've got this system admin sitting at a desk in a basement, and there's probably a sweaty man with a drum, and he beats the drum, and the tickets every time he hits the drum. Richard laughs, which is why I like him. And what that person at the desk would actually do is you'd probably, hopefully, have set up sudo. So they'd say, sudo, make me a virtual machine. And if you go and look at your default Ubuntu install, for example, it will have a sudo config that looks like what's on the screen now. And this is line noise, but what it says is members of the group called sudo on any host can execute any command. With an extra all that I can't really explain right now. And, hey, this is, what OpenStack did originally. We had, subprocess.call calls, and we'd have a command line that needed to use root, so we'd put a sudo at the beginning. And you'd add your, OpenStack user, the user that's running the OpenStack process, into your sudoers group, and it was puppies and kittens the whole way down. That's not super great, because that means that the OpenStack processes can execute any command as root, which is probably not desirable. You can do a little bit better. You can specify exactly what commands sudo can allow access to. So in this case, members of the sudo group can execute exactly one binary called binls. So they can list files to their heart's content. They can do that all day. This is, again, not perfect. You can't, for instance, specify exactly what command line you can execute. Well, you sort of can. You can specify what arguments they can use as long as you know exactly those arguments. There's no way to say regex match and say, they can delete files, but only in this subtree of the file system. So OpenStack, in fact, did this as well. And what we said was, aha, we are geniuses because we are OpenStack. And what we'll do is now system admins and deployers and distros and all of those people who take the stuff we produce can ship with a sudo file that specifies all of the commands that we execute. As best as I can tell, because I went back grepping through the code base, we never actually told them what commands we executed. We expected them to grep the code because, we know what we do. It's in the code, dude. Go read the code. Which is not a super great user interface if you're like some random Debian or Fedora person or whatever trying to package things and you don't really understand the system that you're packaging. So because of person last weekend, actionable thing 1. Don't assume somebody else is going to solve your problem for you. The costs to them of having to solve it are way higher than the costs to you. I understand my code, hopefully, because I wrote it. They don't understand it because they didn't. And so they can flail and grep around and guess what you were intending, but the risk of them guessing wrong is really high. So actionable thing 1, don't be a terrible person. So there were some problems with the sudo and a list of commands approach that we just mentioned. So what we did next was a thing called Routewrap. And at this point, we really thought we were geniuses. So sudo would always execute a command called Nova Routewrap. In this case, it's called Nova because I work on compute and compute's code name is Nova. We had one of these binaries for every process that needed to do this escalated permissions thing. That takes a config file, which is what that next bit is, that specifies exactly what commands we expect to execute and say some regex rules about what their arguments are allowed to be, and then the command that the person wants to execute. And this is actually quite a lot better. There's only one command that needs to be in the sudo config. We now have a config file that specifies exactly what we expect to be executed, and we're no longer poking distro employees with sticks. So that's nice. So actionable thing 2. Is there a trivial change you can make that drastically improves security? This was not hard for us to do, right? Like, we'd have to describe the code for Routewrap as trivial. And so, it's embarrassing that we didn't do this originally. Now, this isn't perfect, but it moves the ball a long way. So are there ways in your world that you can move the ball without attaining perfection but still make it better for everyone else? I think actionable thing 3 is interesting, and this one took us a really long time to think of. What are the costs of your design? So if the only mechanism you have for executing a thing with elevated permissions is a command line that's run through sudo, everything suddenly looks like a command line. So in the sudo example, without Routewrap, the cost of, say, listing Etsy in my example was we had to fork a process, which is a little bit expensive, but not super bad. The cost with Routewrap is that we have to fork a process, start a Python interpreter, parse a config file, to then probably fork a process. Now, we actually measured the costs of this. So, that one command line might be part of a series of, say, 10 commands we need to do to set up a network bridge. If you restart a hypervisor node, there might be hundreds of bridges on that node. So this thing can take tens of seconds. So, it's just the costs add up. I think the other cost here is also interesting, and it took me a long time to realise this. We were forcing people to express what they wanted as a command line, and some things are not well expressed as a command line. So, if I want to do something that seems idiomatic in Python, suddenly I can't. I have to find a way to say, here is a Unix command line that does that thing instead, which is actually not super fun. So which of these examples, and these are real examples from our code base, are reasonable to execute as root with a command line? I actually think the first one is reasonable. So shred is actually interesting. So if you haven't encountered it, shred is the command you run as the FBI breaks down your front door to destroy the data permanently on your disk. It's going to toggle bytes over and over again until they can no longer extract them. So in order to do that, it needs to guarantee a few things. When you write a byte to disk, it must make it to disk. If you have some sort of RAID controller sitting in between saying, well, you wrote that byte 3 times, so therefore only the last value matters, you haven't achieved your FBI bamboozling cause. It does a bunch of stuff to turn off buffering and so on. Like, it's got to tell the kernel, I really, truly, really intend to turn off all your performance improvements to hit disk as much as possible. So you probably wouldn't rewrite that in Python. The other 3 are a bit more questionable, I think. So touching a file, removing a path, making a directory recursively are all easily expressible as command lines. But for example, error checking is much harder. So we have to start parsing the output of commands, or at least their exit codes, to determine what they're doing. But none of these are my favourite. This is my personal favourite. I think I just stopped working. This is my personal all-time favourite command line from a real actual live Nova. So I know what this code does because I read it like last week, and then I meditated on it. And it seems obvious to me, and I feel very smart now. But it's not obvious to someone who's just flailing around in the code base trying to work out why something doesn't work. So what this command line does is it writes a 0 to a sysctl that controls the way multicast works on a bridge. And if it gets back an exit code that's either 0 or 1, we're good. Otherwise, it raises an exception. Helpfully, the exception, by the way, is process exception. So good luck working out exactly what went wrong. This code happens in a context, right? It was in the middle of a method that had 5 other command lines in it, with no commentary around it about exactly what it was doing. It's pretty much as if the author took a shell script that did this thing and wrapped it in some gumph to make it work in our framework. So if we were to rewrite this method as Python that could run as root, it would look like this. And I feel like that's a lot more idiomatic. It's not perfect yet because, it's not obvious that it's a sysctl or that it's a multicast thing unless you meditate upon the command line. But it's at least Python and not bonkers. It also has, even though we haven't done any error checking, it has better error checking, right? So, we'll get an exception that says that file name or that path doesn't exist. If it doesn't exist, we won't get process exception. If we don't have permissions to write to it for some unknown reason, we'll get an exception that tells us that thing. So it would be cool if we could write a lot of our stuff just as Python. It would also give us the option of pushing the business logic down to where the thing happens. Instead of having a method that says, I'll write 0 to any path you give me, we could write a method that says, I know that this must be a valid name for a bridge sysctl, for example. So actionable thing 4, hire Angus Lees and make him really angry. So Angus was a guy on our team. He's much, much smarter than me. And we all thought we were terribly clever with Routewrap. And he came along and said, you people are bad people, and you should be ashamed. And he's actually the one who did the timings, for instance, and said, you know, Neutron, the networking part of OpenStack, has a serious performance problem because of this behaviour. And so he sat down and decided to make this better. And I think we were kind of contextually lucky in that he worked on a team where we didn't have really strongly focused goals based on a product roadmap. We had the scope to say, we agree, that looks like a thing that should be done, go do it. And so he had time to do this nicely. He could have written something that just took command lines and ran them and returned the results. But because he is an intelligent human being, what he gave us was a way to say, this Python method, decorate it with this magic decorator, and this method now executes as root when all the rest of your code doesn't. And it will bubble exceptions across the control bus and all of this kind of stuff, and it's really cool. The only thing it doesn't really do at the moment is you can't pass file handles backwards and forwards. That's technically possible, but when we went to use it, we couldn't find an example where we actually needed that. So, you know, because what we'd do is we would just push all the file handling down into the privileged bit. We couldn't find a reason where you wouldn't want to do that in real-world use for us. So the T example could become something like this. That first line is a decorator that I agree is a bit opaque. But basically what it says is, this method shall run as root. It's actually not strictly true. What it says is this thing should run in the sysadmin context, which is what the Linux kernel calls groups of permissions. And this is equivalent to what you have with sudo. We could, for example, also write something that says this thing is a network admin, but not a disk admin. So a thing that controls bridges probably doesn't need to be able to read all the files on your file system, and you can be that granular. We'll get back to that later on. But, you know, we can have a method name that says, you know, we know what this thing does, so it's not like totally bonkers. We can calculate the path so that we only do this thing to bridges instead of writing 0 to Etsy password or something. We can do some, you know, error checking and raise exceptions that aren't horrible, and so on. So this is a lot better. So I think that brings us to actionable thing 4, which is make it easy to do the right thing and hard to do the wrong thing. So Rusty Russell back in the day, I'm very, very old, and back when LCA was a new conference, Rusty would come to conferences and he was in the process of trying to fix the APIs inside the Linux kernel, because there were lots of places where if you called the API the way that seemed obvious, it was also the wrong way to call the API. And so you'd end up with these unexpected bugs where everybody was like, yeah, that looks like code and totally should work, and it very much didn't. APIs should encourage you to use them in the way that you expect to use them and to get a correct response. I think in general that's not true. Like, nobody deliberately writes an API that's terrible. It happens because APIs organically change over time. So I think maybe the takeaway there, that's not an actionable thing, is take another look at your APIs. Like, if you've got APIs that have been sitting around for a long time, do they still make sense? Is it time to sit back and say, well, we make people jump through weird hoops now to do this thing. Let's simplify and clean up. The other thing that we did wrong here is sometimes we need to make a directory as root. So we would do this, you know, sudo command line thing. The reality is that became the prevalent example in our code base of how to make a directory. So there were, in fact, lots of examples in our code where you didn't need root permissions to make a directory, but people were still shelling out to a command line to do a trivial thing and, you know, with a performance impact, because they were just grepping for previous examples and copying them. And so when I went through cleaning this up, I actually spent heaps of time cleaning up stuff that had no reason to exist, apart from that the developer was in a hurry and had grepped for an example and copied it. There are some other things to know about Proofset. Proofset is the name of the library that Angus wrote. Or, because it's OpenStack and it can't be that easy, it's actually called Oslo Proofset. Oslo means nothing, apart from OpenStack library. You're welcome. Proofset will work for any Python package. There's nothing about OpenStack's helper libraries that is OpenStack specific. Like, that's generally true. We release them all on pip. They're all actually not totally bonkers. Sometimes they make assumptions about how our configurations flags are used, but that's not super bad. Thank you. So this could work for your Python code if you wanted it to right now. The only catch is you need a way to start your helpers with escalated permissions. We actually still use Routewrap to do that thing. It's the only place we use Routewrap now, and the Routewrap configs are just like, I will allow you to start a Proofset helper. But alternatively, you could start your binary with escalated permissions, start the helper, drop the permissions, do the rest of your thing, which is a fairly common model. We chose not to do that thing, or to do it that way, I guess I should say, because if the helper crashes, which we've never observed in the wild, but we're being a bit conservative, Proofset will restart the helper if it can. So if you use Routewrap or something like that to start the helper crashes, that's okay, we just start a new one. Whereas we talked about starting with systemd or dropping permissions or whatever, and we couldn't come up with a way with any of those to restart the helper without implying restart all of OpenStack, which is a very expensive thing to do. So yeah, if you have specifically this kind of escalated permissions problem, you should probably have a look at Proofset. I'm not going to talk specifically about how to set it up in your code. Firstly, because that's fairly well documented already, and because I think I have about 2 minutes left in my talk slot. But yeah, I'm happy if people want to hassle me or whatever to have a chat about it. So in summary of my actionable points, because I'm super proud that I have action items in my War Stories talk now, don't assume somebody else will solve your security problem for you. Think about trivial changes you can make that improve things, even if they're not perfect. Think about the costs of your design, and the costs aren't necessarily just in terms of, say, CPU cycles. They might be in terms of, what am I teaching other people in this code base to do? Hire smart people, let them get angry, and then listen to them. And make it easy to do things the right way, and hard to do things the wrong way. Again, I think the kernel people have a term, path of least astonishment. Whatever you do should never be astonishing. Like I locked my car and it caught on fire. Slightly astonishing, right? That's not the user interface you expect. The car is more secure as a smouldering heap. But, so think about what would a user expect to happen when you did this thing. A couple of quick final notes. I really struggled with writing this talk. I think mostly because I lived this, so none of this seems super interesting to me. So what I actually did is I wrote it verbatim as a blog post first. And so when I walk out of this room, I'll hit publish on that. So, you're welcome to my slides or whatever, but if you just want a big pile of text to read, then that's available. There's also, like I said, examples of how to use Proofset on my site, and I'm more than happy to talk to people about how to get Proofset working, or even if there's a general case that isn't privilege separation that you want to talk about, I'm happy to chat. And that is all I have, and I hope I finished approximately on time. Yeah. Yay!
Thank you very much.
Oh, thank you.
And here's a mug for giving us a talk.
That's good, because my Airbnb only has tiny, tiny mugs, and it was angering me this morning.
Are they like the ones out here?
Yeah.
Yes, we have time for some questions, and we do have a second mic, so we don't have to do as much running. So, who wants to be the first cab off the rank? I can't see past the lights. You're gonna have to be obvious too, because I can't see that great.
I think I'm too scary. All right, I'll ask you a question then. What is this duck thing? I'm like 41, and I don't know what you people are talking about.
So out of interest, did you also consider using things like systemd also lets you specify which capacities you need? So something like that as well?
Mm-hmm. So in my head, I said this at the beginning, but I don't think I actually did. One of the interesting problems that OpenStack has is lots of people use it for building public clouds. And so the only thing we know about the people calling our REST APIs is their credit card number, and it's probably fraudulent. So we didn't want the entire binary running with escalated permissions. We wanted to kind of constrain it more. The other problem we have is that, say, Nova goes and grabs a whole bunch of code from other libraries. And some of those libraries are from pip. So we don't want to trust other people to be giving us code that would run with escalated permissions. We wanted a very clear boundary around the bit that's scary, if that makes sense. I've terrified you all.
Have you got at least one good war story for us?
Yeah, g'day folks. I was looking forward to some war stories. Do you have time for a short one?
Oh. Never worked for a company that's acquired by a private equity firm? That's not really a war story. That's anecdata, I suppose. The original version of this talk that kind of only existed in my head had a lot of ranting about this copied example case. So I was just horrified when I went to start cleaning this up and discovered that there were people out there who thought it was okay to shell out to a command line to make a directory. And there were lots and lots of examples of that, despite the fact that we had a utility method to do that that pre-existed their involvement in the project. And so, you know, I was going to rant about that, and it was going to be hilarious. It was going to be great. But the reality is we gave them lots of bad examples, right? We didn't show them how to do it properly. And I think most code bases are probably like that. There's one down the front here.
Just, I guess, supplementary to that, did you end up writing, I guess, a style guide for OpenStack to guide people who are coming into the code base to say, look, here's how we expect you to do creating a directory or moving things around, or here's how you get an escalated privilege if you know, for this command? It's
a great question. Yes and no. So there's actually an excellent research paper that I don't remember the exact title of, so I'll paraphrase, but it's basically how Wikipedia destroyed their community. And what it talks about is the way you destroy a community is by having a whole bunch of robots that say no, because humans don't really like saying no. OpenStack does exactly that. So we have this huge CI infrastructure that we run CI on every one of our Python dependencies from pip. We often find bugs before the upstream authors do. But we have lots and lots of robots. There's a thing called hacking that will come along and say, no, 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 that's not how you do root. And a human will never even look at your patch, because if it's got a negative vote from one of these robots, it's game over for you. So that's not a thing we solve well. The reason we did that was because when I was actively reviewing Nova code, like we were getting 300 or 400 patches a day, like no human could keep up. And so we had to do something even though it was terrible. What we actually did was we used to have a helper method that said, you know, execute this command line for me. We still have that helper method, but we took away the flags that said run this thing as root. So you'd have to explicitly want to, you know, kind of jump past that helper method now to do that thing. And then we trained the code review team to look for what to look for. And, you know, maybe over time they'll forget and put something else in that's terrible, but then I'll make fun of them and it will be okay. So no, style guide's good. Google does them really well, as best as I can tell. A lot of their style guides are online. And they seem to be mostly, you know, our style guide says never do this thing because we did this really embarrassing, terrible thing, kind of like really applied. But no, OpenStack doesn't have any good examples of those.
Well, thank you very much. Another round of applause. You got more information.
Thank you.